Good afternoon, everyone. It's always good to be on the last block of talks. Let's have a quick look over the agenda that we have. I'm going to go really quickly over my personal part. I will go a little bit in depth why I'm talking about penDXL and response, active response. I will stop a little bit in depth also how the penDXL itself works, and I will explain how it can or could be used. And I will have also a proof of concept. Let's then take a look of the future work that can be done based on the already done proof of concept and where it could evolve. We are not yet talking when we have the topic of penDXL about machine learning or artificial intelligence or stuff like that, but we are discussing a little bit about robots, because in the proof of concept I use small robots actually that are not so smart, but they do the job well. About myself, I have worked for Estonian government for a long time. I started with Data Protection Inspectorate, then I worked a little bit for Estonian Criminal Police as a fraud investigator. Then I thought that it would be good to warm up my IT skills and went to work to a Swedish-owned telco called Tele2. Spent quite many years there, and then moved to CERT EE. And I worked there for 7 years. And now I am part of this NATO's Center of Excellence that's based on Estonia, Tallinn. In response to first day's keynote speaker that when we talk about incident response and awareness raising, then we use usually scaring tactics. Actually, that's not true. When I was at Estonian CERT, we also created a small TV series to promote awareness, how to use computers correctly. About CCD-COE, we have a multinational organization. We are, and we do research training exercises on 4 basic topics. That's technology, strategy, operations, law. Why is it important is that in our research areas, especially for if we talk about technical research, then we focus on all kinds of systems that have relations to military. But since we're a research organization, that's the reason why I'm able to stand in front of you and speak quite freely. And the military uses quite a lot of commercial off-the-shelf products, and that is also one of the reasons why the penDXL is under my investigation or research to see what it can be done and how it can be exploited. And I will come back to this in next slides again. We also focus on all the vital services. That's basically 2 vital services are important to all of us. That's electricity and communications nowadays. And we explore various methods of attacking them and protecting them. And that's one of the reasons also why the penDXL is under my investigation. Close to the topic is we run quite many exercises. The biggest one probably is Lock Shields. That's open to everyone, and it's a blue team based exercise actually, or blue team focused. There are many teams, like 20 teams, that each one has to defend a system they know nothing about before. And there is a crosswords exercise, that's closed one, that's military exercise, and that's red team focused mostly. Why I'm talking about this is that who has ever participated in cybersecurity exercise? Okay. Have you been in blue team? Yeah, okay. Have you been in green team or red team? No. If you have been a part of blue team, you know that your task is usually quite interesting. And that's the last year's network map we had. We have various systems that blue teams have to defend. And they have a full conference room of red team members who are attacking their systems. There are literally hundreds of hackers that are after their systems. It's last year's map, so I can show it freely. And we have all kind of specialized systems also. We have real military drones there that the blue teams have to protect. There is a real power station there that they have to protect. And there is also the industrial control systems that they have to protect. And they know nothing about it before the exercise. So in this environment, they have to move quite quickly because they have 2 days and they have to defend all the infrastructure. So they need some sort of mechanism in place, how to do it fast, how to react to events that in real life actually take a little bit longer, but in exercise situation, you have to respond to them immediately, almost. And since they literally arrive by plane to the strange country and are given the system that they have to protect, they don't have too much time to set up anything before. So they need some sort of mechanism how to deploy the means of protection that react to their commands quickly. When we talk about incident response and acting quickly, then there is a small slide that I borrowed from our corporate slide deck that shows the growth of cyberspace. And if you're part of security incident handling team, you know that your team doesn't grow in that direction. It's pretty stable because there are not too many people. So one way to handle the ever-growing cyberspace is to develop the tools and mechanisms to handle the incidents more efficient way. If you are part of, if you have been part or you currently are part of a security incident handling team, then you know that there are various expectations from you, and there is a real life. Real life is that you actually have many different devices that or applications that should communicate each other, but sometimes they don't, or usually they don't. So the sad reality is that in many cases you do have to deal with the bottom right thing, that what you actually do is copy information from one place to another in order to make your network safer. So we are handling a quite large amount of incidents and events with different tools and appliances. The integration could be better. And sometimes it takes hundreds and hundreds of man-hours to make things work together. And since the products evolve quite furiously sometimes, then you can't really keep them up, keep them working together all the time. And there's a lack of time and people, as usually, and money. So then comes a new term, active response, that I looked for a term or definition of the term for a long time, and I couldn't really find any. So what it is active response what it is? Is it about blocking? Then if we look at corporate information sources, then the blocking is, yeah, that's by their definition, it's active response. Who thinks that blocking is active response? I do. Who thinks that deception could be active response, meaning that you react to a threat by isolating, or possible compromise by isolating the resource and putting in a segregated environment so that you could investigate a little bit later. Is the active response about attribution, or is it about getting even or getting back? So there are many questions, and that's the questions we need to discuss before we implement them in a technical level. Because if we build a good system that's going to hack back somebody automatically, then we may be in trouble. So, in order to have active protection, there are defined the 6 conditions by one man. That you should have centralized event management, you should have some kind of analytical skills, you should have open APIs, and you should have dynamic infrastructure that you can configure and run. And you have to have the people who will make decisions, and you have to have the visibility. If you think back about the Lockshields network map that I showed you, then there are not all the elements can be covered in this situation. So when I started to explore the options, how to help the blue teams, how to make their life easier, to provide them with a tool to either fully automate or make their response a little bit more automated and faster, then I stumbled up into the McAfee's contribution to the world. It looks like this year they went really active and said that we are using penDXL called thingy, and it's gonna be the backbone of our products in future, and it's open. You can connect your devices to it. And that's something new. Usually the industry says that, oh, that's my proprietary thingy. You can't really connect to it directly, just via API. And when we look a little bit closer what the penDXL itself is, it's actually the borrowed technology from the Internet of Things world. It's based on MQTT. That was also the topic of last day's first section. And it's basically the huge data bus that has one broker that takes care of distributing the messages and queuing them. And there are publishers and there are subscribers. Nothing really complicated. The standard is quite open. When they said it's penDXL, then there's a word open in it. So I went after looking for any standards that they may have on how to use it. It turns out that there are not any. Actually, the open means that the components are available from GitHub. And nowadays they made a broker available as a Docker image as well. So we don't have to use McAfee this infrastructure or commercial components at all. We are free to use all the open source and build our system based on open source components. Some features of MQTT is that there are clients that can connect to the broker and send out messages, receive messages, and process them as they are meant to do. It's a binary protocol, means that it's quite fast. It's meant to work in poor conditions. It has sort of querying written into the standard, but actually it's not implemented. So if you're not listening on the data bus, you will lose the information. That's one of the features that we may not really like. When we talk about security, then one of my friends said, yeah, the security, that's the S in IoT. So there is no. Actually, there is. But there's, as usual, there are buts. It's TLS-based communication security. And you can also give per topic-based access. We will talk about topics a little bit later. And it's based on PKI. So you have certificate authority, and you will give certificates to the broker, and you sign with the broker certificate the client certificates. Who has ever run the certificate authority as a service inside house? Was it fun? No. So that may be the first blocking point also, where when we talk about OpenDXL, yeah, they made it secure, but is it easy to implement actually? That's a question mark. When we talk about options, how to use this this OpenDXL in our infrastructure, is two options that I considered. One is the orchestrated way. That's pretty much the nowadays security incident response orchestration, incident response workflow orchestration tools work. So they connect some various devices via APIs, and you will have data coming in, and then you have some kind of nice dashboard when you can connect the dots and say that if this kind of event arrives, then do this. And when we talk about OpenDXL, we'll look how it could be implemented. Another way would be that we have independent agents that respond quickly to the events that appear on the data bus, and the minus side is that actually they would require support from the appliances. And since the way how the MQTT topics are built up is not regulated in OpenDXL, that can be a blocking point as well, because you can take whatever topic you want. And if you talk about independent agents that know nothing about other agents, then bad things can happen and will happen, because they don't usually validate the input. They will just do blindly what they are told. But it's a good starting point, though, because from that point, we can move into the orchestrated system. So let's take a look in this MQTT-based part. An orchestrated solution, we would have the topics. That's actually pretty similar to RESTful API URLs. That's not big difference. The only difference is that in this IoT word borrowed MQTT, it is mostly broadcast way of traffic, so that if you are information provider, then you just push the information from you away, and the broker will distribute it automatically to all the interested parties who have said that, I want to know about that. So in orchestrated setup, the topics would be organized in a more standard way, that you have the company, then you have some kind of service identifier, then you have some kind of service-specific activities. In independent solution, we would actually focus on the data. we will say that we don't really care about what kind of device will handle it. We will say that we have a bad IP, we have compromised IP, and there is a bad file hash, whatever. We just could go by this path. And I have built a proof of concept based on this concept. So, to the real world scenario for the proof of concept. As usually, if you have worked for incident response team, then you know that you usually have to deal with compromised computers, and in many cases it will be the web server that the computer will be compromised from. And in our proof of concept setup, we also have the evil hacker who has compromised the web server, and we have a client who has visited the website at some point of time. And then we have an infrastructure that consists of firewall. It has a history, a keeper, that's NetFlow, actually. And we have the virtual environment where we can take the infected client and revert it to a good known condition. So how it works then is that in the setup we have a broker, we have the agent that is responsible of listening the messages related to compromised clients. Then we have an agent on the gateway that's listening to the information about bad IPs. If he receives such message, it will look up if there's any historical records that reference to the hosts inside our network. And then if he finds it, it just publishes it to the DXL channel, saying that we have a possibly compromised IP. And then we have some external server that can be anything. It can be honeynet sensor, it can be a sandbox, it can be some kind of data feed, whatever. And how it works is that when we built the system, that, as I said, we will not use any commercial components because it's possible. It takes about 5 minutes to set up the central server, and it is quite well set up, well equipped. You can get all the client configuration that you need to build a client with a one click of a button. And we have firewall agent that's interfaced to Linux IP tables, since there are no commercially available firewalls yet that would speak MQTT or OpenDXL. And it responds to the events, and it will just apply the deny rule. We have NetFlow agent, as I said, it will look up based on the IPv formal version, what the badness from the NetFlow database, and if he finds a match, then just broadcasts the possibly compromised IPv address. The sensor agent is just trailing the log, and when it finds the IP, then it just broadcasts. And we have the VM manager who will listen to the compromised events, and when the IP matches the host he knows something about it, it will revert the machine to known good state. Developing all the components actually took a couple of days, but not because of the OpenDXL part, because it's easy. It's the interfaces to the IP tables, to the virtual box, and to the NetFlow. And how it works is that from the firewall we can see that, well, the deny rule has, there are no deny rules yet. I will run the independent agents that are listening on the OpenDXL data bus. we'll just check that the firewall deny rule has not been applied yet. We will run the external sensor, and we will run the VirtualBox manager. We have the hacked machine. And now we will gonna emit the known bad IP to the file that the sensor is reading. And we can see that immediately the virtual machine agent responded. It reverted the machine to the good known state and booted up the machine again. And we'll also have a quick glimpse on the IP tables. We have now one IP that will be dropped when in order to prevent the future infections. So in 4 simple scripts that now you can set up in your lab, then in 5 minutes, because they're available from GitHub, you can actually set up the system that reacts to information it receives. It's a dumb client, so it will do whatever it is programmed to do. But it's a good starting point. It's a great technology to watch because it's easy to deploy, relatively easy to deploy. It's lightweight, and it's really fast. You can really see immediate reactions to the data that you want to be processed. It can be a bit challenging to deploy on large installations, and mostly because of the security. Because you should generate the client certificates for each device or software installation that you will connect the that you will connect to the OpenDXL bus. The topic, the hierarchical tree of topics should be regulated, because otherwise it will be a zoo, and it's no good for anybody. The minus points would be that if the client that is part of this OpenDXL databus is compromised, then it's at first hard to know if it's compromised. It doesn't show. He or it has access to the data that's on the databus. And since we're dealing with a PKI type of access and access mechanism, then actually eliminating the client from the network can be the puzzle or piece of a puzzle that needs to be solved. So the time will tell if the industry will pick it up and will start using it. My interest is that since the McAfee said that its products will be using it as a central data line for all the applications it has. And we have McAfee also in military side as well in some installations. So we need to keep an eye on it, how it evolves, to know what are the positive and negative sides of it, and to see how it can be exploited and how it can be used in a good way as well. And what can we do with it? Can we connect it to the orchestrated system and have a much more responsive system? The next iteration of this research is going to be automated active response orchestration. So my goal is to have at least not in the next year, but in the year after that, on the LogShields test run, one team that consists of a couple of guys only, and most of the stuff is done by automated tools to see how it works out. It's going to be fun. And that concludes my talk. If you have any questions, I'll be most glad to answer them. You made it to the last section.